folks. I just wanted to make you a few videos to go over all the things we didn't have time to do in class yesterday. Even though we had an extra 20 minutes, I really didn't want to rush, so we have lots of things to cover that we didn't get to talk about. We'll start with the review questions. I saw that you all did them. I'm super pleased that everybody did all of their homework for the first day, and I hope that keeps up all year. I entered your grades on end grade for your homework, so the whole class has 100% average right now, which is lovely to see. So let's look at the review questions. Number 1 says, which of the following contains no matter? Remember we talked about matter in class. Matter is something that has mass and takes up space. So it gives us 4 options: a rock, a balloon full of air, a balloon full of helium, and a lightning bolt. And clearly it wants you to choose the lightning bolt. I love that he starts with this question. I don't actually think that's really true. A lightning bolt is made of a superheated ionized gas, the 4th state of matter called plasma. And so by definition that would be matter. So I'm not convinced that's fully true, but clearly a rock has matter. It has mass, takes space. A balloon, whether it's full of air, completely empty, full of helium, or any other gas, the balloon itself clearly has mass and takes up space. Air has mass and takes up space, as we showed in class. Helium is just another gas, has mass and takes up space. So lightning bolt is clearly the way you want to go with that, even though you could easily dispute that. I think lightning bolt would be matter. But so choose D, even though that may not be completely true. Number 2, list the base metric units used to measure length, mass, time, and volume. We went over that. Length is measured in meters, mass in grams, time in seconds, and volume in liters. You can, of course, add the metric prefixes to those, and that's what we're talking about next. Number 3, in the metric system, what does the prefix centa mean? So centa, wow, I need to be able to see that better. Centa means 1 over 100, or you could write it as a decimal, 1 over 100, or 0.01. Number 4, which has more liquid, a glass holding 0.5 kiloliters or a glass holding 120 milliliters? Okay, so clearly we have volumes that are in different metric units. We have one measurement in kiloliter, one in milliliter. So we need to convert one to the other so that we can compare them with all things being equal. So you could convert kiloliters to milliliters, or you could convert the 120 milliliters to kiloliters, or you could just convert them both to liters. Either way would be fine. So I hope that you can see the board well. I'll try to write bigger. Erase. Okay. So we could write all of our units down, which I hope you will memorize. Kilo, hecto, deca, and then your base unit. Then deci, centa, and milli. Can't really tell if you can see that. So then you would convert. So you have 0.5 kiloliters. And if you convert that to liters or to milliliters, then you can compare. We can tell that there are, let's see, we want to get liters, so we're going to put that in the numerator. We know there are 1,000 kiloliters in a liter. So if we multiply 0.5 by 1,000, we would find that to be 500 liters. You can use your calculator, or you can just move your decimal point 1, 2, 3 places. So then you could also convert 120 milliliters to liters. 120 milliliters. We know that there is 1 liter for every 1,000 milliliters. You can cancel out your unit, milliliter, end up with liter. 120 divided by 1,000, in that case you'll move your decimal point 3 places, so you get 0.120 liters. So now you compare 500 liters to 0.120 liters, and clearly you would find the 0.5 kiloliters to be the larger volume. Make sure that you are comfortable with metric conversions. We will convert unit to unit all year long. Number 5 is how to use a ruler. We talked a lot about how to use rulers, graduated cylinders, all sorts of measuring devices in class. You're supposed to measure a bar in a picture. There will definitely be something similar to this on a test. Remember that you can measure one significant figure between the lines when you do problems like this. So it starts on the 1 centimeter mark. Remember also to subtract 1 centimeter from your final answer if you start on the 1 centimeter mark. If your ruler starts right at the edge and then you have that uncertainty right at the edge of your ruler, you really want to start on the next mark over, not right at the edge. So it starts at the 1, looks like it ends at 3.7 to me, milliliters, or I mean millimeters. So I would say that would be maybe 27, and it looks like it's right on it, so 27.0 millimeters. Or you could say 2.7 centimeters. You need to have 3 significant figures in your answer, whether you report that answer in centimeters, millimeters, what have you. So number 6, you have 2 students measure the mass of a 502.1 gram object. The first student measures the mass to be 496.8123 grams. I'd love to have that scale. The second measures the mass to be 501 grams. Which was more precise? So remember we talked about precision just being the number of significant figures. More precise means you have more significant figures. So that first student had more significant figures, that's more precision. That doesn't mean they're right about the answer, that just means they have more significant figures. Which student was more accurate? Accuracy means closest to the truth. The truth is 502.1 grams. So the second student was closer to that answer, so they are more accurate. First student's more precise, second student's more accurate. Oh, JoJo's here to say hi. He likes to look at himself, sorry.
On number?
Go see Granddad. Alright, so number 7 says, how many significant figures are in the following numbers? So A, I count 6, B, I count 5, C, I count 2, and D, I count 3. You can check your answers, see if you missed that, make sure you review. If you still are stuck and you don't understand why I got those numbers, please call me. We'll make sure we get you squared away on counting significant digits. Oh no, we're not. Let's don't play with the phone. Number 8 says a student measures the mass of an object as 2.32 grams and its volume as 34.56 milliliters. The student then calculates the density to be, wow, this giant number. There are 2 things wrong with the student's value for density. What are they? So when you calculate that density, you would be dividing grams per milliliters. The gram unit, 2.32 grams, has 3 significant figures. Milliliters, 34.56 milliliters, has 4 significant figures. When you're multiplying and dividing, such as calculating density, you have to choose the least number of significant figures in any number that you're using. So that would be the mass measurement, 2.32 grams, has 3 significant figures. You need to round your answer to 3 significant figures in that case. So the student has far too many significant figures. Also, the student has no unit on their answer, and every answer must have a unit So that answer needs 3 significant figures and no more, and it also needs units, grams per milliliter for density. Grams per milliliter for density. Okay, so number 9, why does ice float on top of water? Well, we thought about density a lot in the lab this week. Why does ice float on top of water? Well, why did water float on top of syrup? Why did oil float on top of water? Due to density. The less dense something is, it will float on something that's more dense than it is. So clearly ice must be less dense than water. Number 10, lead has a density of 11.4 grams per milliliter, whereas gold has a density of 19.3 grams per cubic centimeter. If I were to make 2 identical statues, one out of gold and the other out of lead, which would be heavier? So if they have the same volume, they'd be identical, same volume. So which one's going to be heavier? Well, lead has a smaller density than gold because grams per milliliter and grams per cubic centimeter are the same. Because a cubic centimeter is a milliliter. So the statue of gold would be heavier because if they have the same volume, the one with the greater density would have the greater mass. So those are the review questions. I'll be back later with practice problems and an analysis of the lab.